Hi everyone, welcome to my channel. This is Leo, and let's do some more Leetcode problems today. Today's problem is called word ladder. This is categorized as a hard question, but after my description, hopefully it can be easier for you. Okay, so we know a transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words from the begin word to an intermediate word to another one, then finally land on the end word. So every adjacent pair of words differs by only one letter, and every SI is in the word list. So the begin word does not need to be in the word list, and at last, SK should equal to end word. And we were given the two words, begin word and end word, in the dictionary word list. Return the number of words in the shortest transformation sequence from begin word to end word. And if there's no such sequence, we return 0. Okay, so how do we approach this problem? Let's take a look at an example here. The begin word is hit, the end word is cog, word list is this, okay? So how do we change? We first have hit, and then we move to hot, and then we can move to dot, then dog, then cog. That should be the shortest path, okay? So why don't we transform dot to lot? Because if that's the case, after lot, we can only change it to log. And after log, we can change it to cog. And that is longer than dot to dog than to cog. Okay, so yeah, the final result is 5. We're counting from hit, the begin word, to cog, the end word. Okay, so how do we solve this problem? Let's write it out. Okay, so we have a initial word named hit, and we transform it to hot, then dot, then dog, and then cog. Okay, what about the other words? Can we transform hit to another word here? I don't think so. But can we transform hot instead of dot to another word? Yes, we have lot. So here we can transform it to lot. Okay, and next, can we change lot to something else? Of course. We have a dot, right? So we can make a connection here. And can we transform lot to another word? Yes, that would be log. And how about log? Can it be transformed to another word? Yes, we can transform it to dog. And also, after all these, we can transform it to cog. Okay. Yeah, so that should be the graph of our transformation here. So it's pretty clear to all of us. This should be a graph traversal problem. More specifically, since we're finding the shortest transformation sequence, we're doing a BFS. Starting from hit all the way to the end word. And if we can't find any end word here, simply return 0. Okay? So that should be pretty clear, and I will code my thoughts out. So first, we know it's a BFS, right? Second, for BFS, we need to have a queue. In this case, we're going to store some strings in it. And we have a queue, and the queue will add the begin word in it, okay? And we have to calculate the steps that we take from the begin word. So since we're counting the begin word into our final result, we will initially set the steps to 1. Okay. Next, we'll run the BFS, recorded size, and loop through the strings in the queue. And yeah, loop through the strings in the queue. Okay. So after that, let's say we have hit popped out. We're going to find all of its neighbors in the dictionary. Okay. So how do we traverse? How do we find the neighbors of the current word? We're going to traverse by changing one letter in the how do I say that, in the current string. Okay. And what will happen if it's in the dictionary and if it's a match? We return what? We return steps. And remember to +1, because when we find the match was not in the queue and we haven't even touched on it. So we have, since it will be included in the final result, we have to count it in. So we return +1. Okay. So if not in the dictionary, what do? Okay, we do nothing. If in dictionary but not a match, we'll put it in the queue. Okay. Put in the queue, and we have to remove from dictionary. Why is that? Because we're not going to visit it twice. We're finding the shortest path. So we're not going to visit any string twice. Okay. And after this, we can restore the original string cur. And after that, when we processed all the elements in the current queue, we will just increment the steps. Okay. Yeah, that should be the thought process of this problem. Let's code it out. Okay. So we have a queue. And we will add the begin word to the queue, and we'll initialize steps. Okay. And for the dictionary, this is pretty tricky with the dictionary, because if we're going to do some operations like removing something from the dictionary, it's better to know what the key is. Okay. But for the linked list, I don't think key really matters here. So we're going to change it to a hash set to store all the strings in the dictionary to a hash set. Okay. I'm going to call it dictionary, dict. And it's going to take the whole word list. Okay. Next, let's do the BFS. We record the size. And we traverse through all the strings in the current queue. So the current string, let's change it to character array for easier operation with the changing one letter stuff. Okay, so to character array, and since we're changing each letter at a time, we're going to traverse through the current array. Okay, so now we have to find a letter to change. So I'm going to set up a variable with current j, and then we change one letter. Okay, after that, we have to go back, because if, let's say, if we don't have the first word, first letter in this dictionary, let's say we have something starting from A, then we cannot find anything here with the first word. So what do we do then? We go to the next letter, okay? Change one letter at a time. So once we're done with it, we have to change it back. So current j equals to temp. Okay. Now we change one letter. So for character C equals to A, C is less than or equal to Z, C++. Yeah, the current j equals to C. We're going to change it to C. And if, let's say, next equals to new string, cur, if the dictionary contains this string, like I said, if it's a match, next equals to what? End word. We're going to return steps plus 1. Else, if it's not the end word, we'll just put it in the queue. And we have to remove it from the set because we don't want to visit it twice. Okay, so that should give us the right answer. After changing the character, we have to put it back. Okay, and after this iteration, we have to increment steps because we're going to operate on the next level. And if everything goes well, we should return the steps here. Okay, and if it doesn't go well, we'll return 0 here. Okay. Oh. Okay. All right, I think it passes. Okay, so this doesn't look so hard, right? Let's analyze the complexities, okay? So for time complexity, we're doing some traversal here. We should have all the words in the word list here. And we're traversing through all the letters there. So it's, if this is M and this will be N, and each time we change a character, it's a constant, but forming a new string will take the length of the current word, okay, time. So all in all, we're going to have M squared times N, where M is the length of each word in the dictionary, and N is the length of the dictionary itself, okay? And for space complexity, we have a queue, and at each time, we form a new character, form a new string, and we are we doing anything else? No, so it should be M by N because we're because of the set. And we have the queue, so every time we have to process it. So the space complexity would be m squared by n as well. Okay, it passes all the test cases. Thank you very much for watching, and I'll see you in our next video.